All right, this is lesson 412, negative integer exponents. Now this is going to be a little bit crazy to some of you, so you might want to really concentrate on this, and you may have to pause it, go back and see what's going on here. But just to give you some sense about this, so check out this list of numbers here. We start with the fraction 127. If we multiply that by 3, we get 1/9. Multiply that by 3, we get 1/3. We multiply that by 3, we get 1 times 3 is 3 times 3 is 9 times 3 is 27. So what number could follow 27? That would be 27 times 3, which is 81. What number would precede 127? Well, that would be, working backwards, that would be 127 divided by 3, which is the same as 1/3 times 127, which is 1/81. So if we go this way, we have numbers like 1/81, and if we go back one more, just like this way, we would have 81 times 3 is 243, times 3 is 729. Working backwards, we would have numbers like 1/243. So if we divide that by 3 again, we would have 1/729. Notice the similarities to the numbers. And if we use exponents with the same base to represent these numbers, 27 would be 3 to the third, because starting with 1, we multiplied by 3 times to get there, which is 3 to the third. 9 would be 3 to the second. 3 would be 3 to the first. Of course, 1 is 3 to the 0. And so if we assume this pattern continues, the numbers we would have for 1, 1/3, 1/9, and 1/27 would be 3 to the 0, 3 to the negative first, 3 to the negative second, 3 to the negative third, and so on. Our number here, 1/81, would be 3 to the negative fourth. So this gives us some idea of what negative exponents mean. Let me show you that in another way. I think a couple of examples are going to be needed here. What if we had a table? So here's those problems we just did, powers of 3, and we know that 3 to the first power is 3, so let's just start there. And if I go this way, I'm just multiplying by 3 again. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, so 3 to the fifth is 81 times 3, which is 43. Now if I go this way, to get from 3 to 3 to the 0, it makes sense that I need to divide by 3. So moving backwards, I'm going to keep dividing by 3. Divide by 3, divide by 3, and so on. So 3 divided by 3, I can do that in my head, that's 1. So 3 to the 0 is 1. 1 divided by 3 is 0.3 repeating, or as a fraction is 1/3. At this point, I think I'll use my calculator to demonstrate what I'm doing. So I was at 3 to the 0 power, which I hope you're starting to realize now that that would be 1. 3 to the 0 is 1. And if I want 3 to the negative first, that means I'm going back one step. So that means I need to divide by 3. And I want to turn my answer into a fraction, so I'm going to press my math button. And fraction and enter. And so now I'm at 1/3. If I divide that by 3 again, I get 1/9. Divide that by 3 again, I get 1/27, and so on. So 1/3 divided by 3, or 3 to the negative second, is 1/9. 3 to the negative third is 1/27. 3 to the negative fourth is 1/81. And in general, you can see that this denominator for 3 to the negative first is the same as 3 to the first. this denominator for 3 to the negative second is the same as 3 to the second. So that leads to a property that we can use for negative exponents, that any number with a negative exponent is equal to 1 over that number with a positive exponent. What I'm saying is 3 to the negative second equals 1 over 3 to the second, or 1 over 9. And I'll give a couple more examples so that you can understand that better. You can look at these examples if you want. I'll do a couple more. So if you look at your paper, example 3 gives us an opportunity to use that property. So 5 to the negative third, and I'll show you one more time on a calculator what I'm talking about. But if we think of 5 to the 0, we're at 1. And so this negative third is dividing by 5 3 times. So I can think of it as 1 divided by 5. And doing that 3 times, I can represent that with an exponent 3, which is 1 over 1/25. So 5 to the negative third, I can rewrite as 1 over 5 to the third. And just to show you that that's true, so I'm trying to find 5 to the negative third here. And we can do it just by using my caret button. And then to turn that into a fraction, I do that, and there it is, 1 over 1/25. But just to show you that that makes sense, if I do 5 to the 0, now I hope by this time you know what this answer is going to be, 1. Now if I divide that by 5, so I'm doing now 5 to the negative first power, because I'm dividing, starting at 5 to the 0 and going back 1. And if I change that into a fraction, enter, that's 1/5, that's 5 to the negative first. Do it one more time, that's 5 to the negative second. Do it one more time, that's 5 to the negative third. All right, so 3 to the negative fourth is 1 over 3 to the fourth. And 3 to the fourth power is 81. 6 to the negative fourth is 1 over 6 to the positive fourth power, which is 1 over, let's see what the calculator says that on that one. 6 to the negative fourth, change that into a fraction. Oh, that's given us scientific notation, which we don't want. So what I'm going to do to fix that is I know that 6 to the 0 power is 1. Now I'm just going to divide by 6 4 times. And change it into a fraction each time. And so I get 1/6, that's negative first, negative second, negative third. And on that one, I get negative fourth, but if I just do 6 to the fourth power using a positive, it'll give me the number 1,296. So I know that 6 to the positive fourth power is 1,296, so 6 to the negative fourth power is 1 over 1,296. So if I have negative 7 as my base, it's 1 over that base, negative 7, only now it's a positive exponent, so I need to know what negative 7 to the 8th power is. Get this as a fraction, so I'm going to put 1 over and figure out what negative 7 to the 8th power is on my calculator. So negative 7, and I'm going to use parentheses here. If I don't, I'm not going to get the right answer. I possibly won't get the right answer, actually. I won't in this case. 5,764,801. All right. So I'm going to add one example here, a couple examples here, another situation. You can slip these in here, but what if we have a fraction like 2/3 and we raise that to a negative power, say -2? Well, if I was doing just 2/3 to the positive power of 2, that would be 2/3 times 2/3, which is equal to 4/9. And you might notice that I'm multiplying 2 by itself twice and 3 by itself twice. So really I can think of this as 2 to the second over 3 to the second. All right, well, making that a negative exponent, 2/3 to the negative second power. I'm going to use my calculator again to help me with that. So I want 2/3 to the negative second. I'm going to start by doing 2/3 to the 0 power. And, of course, that equals 1. Then I'm going to divide it by 2/3 because going back, negative exponents are dividing by that amount. So divided by, use parentheses to represent my fraction and the divide sign. 2/3. I want to change that to a fraction. And press enter. So that's 2/3 to the negative first. And that's 2/3 to the negative second, 9/4. So that equals 9/4. Now let's look closely at that. That was, remember, 2/3 to the second, positive second was 4/9, and 2/3 to the negative second is 9/4, which is the reciprocal of that number. So it looks to me like possibly 2/3 to the negative second is the same as 3/2 to the second. Now let's try that with one more fraction. Like, let's say we have 1/2 to the negative third. So if I follow that idea, then I'm thinking that's the same as 2/1 to the third. And I'm not going to put 2/1 because 2/1 is the same as just 2 to the third. So this is my conjecture here. I think it might be true. Let's use a calculator to see if that is true. So we want to do 1/2 to the negative third. 1/2, and you can do 0.5 if you want, but I'll use this, to the negative third power. And I want to see that as a fraction. Actually, I don't need to because I think it equals 8, which is the same as 2 to the third. And it does. 1/2 to the negative third is equal to 2 to the third. Let's try one more here. What about, let's make another 3/4 for my fraction. 3 divided by 4. Let's do that to the negative third power. And I'm going to change that to a fraction. That's 64/27. Is that the same as 4/3 to the positive third power? And change it to a fraction. It is. So we have a way to deal with fractions with negative exponents here. We have that. This was the last example I did. 3/4 to the negative third is equal to 4/3. The third, which is just 4/3 times 4/3 times 4/3, or 4/3 over 3/3. And 4 times 4 times 4 is 64, and 3 times 3 times 3 is 27. So we have some new strategies of dealing with negative exponents. I'm going to end the video here, and we'll work on some of those in class.